This is the lesson video for Algebra 1 Summer School, Unit 3, Lesson 2, Function Notation Part 1. So these are the notes for Part 1, and then we'll have another video for the practices at the end. So let's do a review here. We've been working with linear equations this year in the form of y equals 3x minus 10. Using this equation, we're going to find the value of y when x equals 7. All right, so this is something that you would have done in pre-algebra. So what we have to do here is we're going to take that x equals 7 and we're going to substitute it into the equation for x equals 7. So in doing that, we're going to have y equals 3. Now instead of x, this time we're going to put a 7 minus 10. Now all we have to do is simplify to find the value of y. We end up having y equals 3 times 7 is 21 minus 10. 21, not 27. 21 minus 10, which equals 11. Right? Now, if we use the same equation, it says, what about finding the value of x when y equals 50? So this time what I have to do is take the value of 50 and put it in for y, because it says I'm searching for the value of x. So I'm going to take 50 equals 3x minus 10. Now this takes us back to Unit 1, which was solving equations. So I'm going to go ahead and draw my line to keep organized, and I'm going to get x all by itself. I start that by adding 10 to both sides, which gives me 60 equals 3x, and then I have to divide by 3 to get x alone. My final answer ends up being 20 equals x. So it turns out that 20 is the x value that gives me a y value of 50. Now, in the past it says, we have learned in the last unit that functions, right, are relations that follow the rule of having only one y value for every x value. That's the definition of a function. Every x value has only one corresponding y value. And since functions are rules that convert inputs into outputs, it makes sense that they have their own fancy notation. The notation we're going to see in the next couple examples looks like this. Okay? That looks kind of weird, but it's said as f of x. F stands for function, the function of x. And we're going to see what happens when I have that f of x notation. I'll give you a hint. It's not any different than the very first example we just did. Okay. So it says, example 1, for each of the following functions, find the outputs for the given inputs. Then represent your solution as an ordered pair. We'll talk about all of that as we go. So in A, it says we have the function f of x equals 3x plus 7. Now when I look at the function, I should notice that inside the parentheses is an x. That means that every time I have function notation here, like f of 2, that 2 is an x value. Because the 2 is in the spot of the x, I'm going to take 2 and put it in for x in the function. So I will have 3 times 2 plus 7. All right, well, 3 times 2 is 6. 6 plus 7 equals 13. So when I put 2 into the function for x, the final answer that I get ends up being a y value. So the input in the parentheses is an x. The answer is an output, or a y. The directions say to write your solution as an ordered pair. Well, remember, ordered pairs have an x and a y value. So in this example, 2 was my x value, and 13 was the corresponding output y value. All right, let's do the same thing for f of negative 3. It seems that negative 3 is in the parentheses, so it's an x value. So I'm going to put it in for x. 3 times negative 3 plus 7. I want to figure out what that equals. Well, 3 times negative 3 is negative 9. And negative 9 plus 7 equals negative 2. Okay, so that negative 2 is a y value for me, which means that when I write my ordered pair, I have the x value of negative 3 corresponding to the y value, the output of negative 2. All right, I'm going to do the same thing for 2 other functions here. So that was A. In B, I have the function g of x. Okay, so g of x equals x minus 6 over 2. Right, so here I have g of 20. 20 is my x value. So I'm going to put that x in to the function for x. So I get 20 minus 6 in the numerator, all over 2. Right, 20 minus 6 is 14, and 14 over 2 equals 7. Right, that 7 is a y value. Excuse me. So my ordered pair solution is 20, comma 7. That's the ordered pair that represents the 20 as the input and getting 7 as the output. All right, next we have g of 0. 0 is an x value. So I'm going to take 0 and put it into the function where x was. Notice x was here in the numerator. Well, 0 minus 6 is negative 6 divided by 2, which equals negative 3. And negative 3 is the output and the y value. So if I was going to write my solution, my input and my output as an ordered pair, I would have this solution 0, negative 3. So if I were to graph this function g of x and plot a bunch of points, the point 0, negative 3 would be on the graph. All right, last one for this example is C, h of x. H of x equals square root of 2x plus 1. I'm going to start the same way as the others. H of 4 gives me 4 as an x value. So underneath this square root, I'm going to take 2 times 4 plus 1. Well, it's still all under the square root, and 2 times 4 is 8 plus 1. Well, 8 plus 1 is 9, and I have the square root of 9. And we should know that the square root of 9 equals 3. So I have an input of x value of 4 and a y value output of 3. So the ordered pair that would represent this function would be 4, comma 3. Finally, h of 0. Right, 0 is an x value. I'm going to do the same thing as I did in the first part, and I'm going to put 0 under the square root for x. 2 times 0 plus 1. Well, 2 times 0 is 0, so I just have 0 plus 1 now, and that equals the square root of 1. The square root of 1 is the value of 1. That's my answer. That's the y value, which gives me, then I can write an ordered pair of 0, comma 1. All right, so we've seen 3 examples of different functions. And here's a little note that function notation can be very, very confusing because in reality, it kind of looks like multiplication just because of the parentheses. But we have to be really careful and note that there is no multiplication involved here. This notation serves us 2 purposes. The first is to tell us what the rule is. The rule is like x squared plus 1, whatever the equation is. And 2, it gives us an output for an input. Okay. So just a reminder here, function notation. What's in the parentheses is always my input. It's always an x. The answer, what the whole thing equals when I put x in, is a y value. Well, let's deal a little more with the y values here on the back of your note sheet. In example 2, it says, given the function f of x equals x over 3 plus 7, do the following. Then represents your solutions as ordered pairs. So this first one in H is very similar to the problems that we did on the front of your notes. F of 6. 6 is in the parentheses, so 6 is an x value. So if I'm going to find f of 6, I'm going to take 6 and put it where x is in the function. So I get 6 over 3 plus 7. Well, 6 over 3 is 2. And then I have 2 plus 7, which equals 9. 9 is my answer, which we said is always a y value. So my ordered pair for this function is 6, comma 9. That's exactly the same as what we were doing on the front. Same in B. I have here that f of negative 9. I'm trying to find the output for the input, the x value of negative 9. So I'm going to start the same way. I'm going to put negative 9 in for x. So I have negative 9 over 3 plus 7. Negative 9, excuse me. Excuse me. Negative 9 divided by 3 is negative 3 plus 7, which equals 4. That 4 is a y value. Because I have an x and I have a y that corresponds and matches to it, I can write the ordered pair, negative 9, 4. Now here's the tricky one that we have to be very careful when we read. Find the input. Input is the x value for which f of x equals 13. Well, notice here, I don't have 13 in the parentheses. So this time, 13 is not an x value. 13 is a y value because it's what it equals. So this time what I'm going to do is I'm going to replace f of x, what the y is here, with 13. So I'm going to write the equation 13 equals x over 3 plus 7. Okay. I need to find the value of x, so I have to have an x in my equation. Well, now I need to solve this equation. So I'm going to do what we did in the very first review example. I'm going to draw my line to keep organized, and I'm going to start by getting x by itself. Notice x is in a fraction right here, so I have to deal with what is outside of the fraction before I can get to the x. So that means I have to start by moving 7, subtracting it from both sides. 13 minus 7 is 6, so I have 6 equals x over 3. Now I have the fraction all by itself. I need to move the denominator, which I do by multiplying both sides by 3, which gives me 18 equals x. That's a really good thing. I now know the x value that corresponds with the y value of 13. So when I write my ordered pair, I'm going to take this x value and put it first, 18, comma, 13. All right, one more example. Let's practice going both ways with the function, giving an input and also being given an output. This time I have a function g of x, which equals 3x minus 5. It says find the following, then represent your solution as an ordered pair. First, we're going to find g of 4. 4 is in the parentheses, so it's an x value. When I put 4 into this function, I have 3 times 4 minus 5. Well, 3 times 4 equals 12. Now 12 minus 5, and that equals 7. 7 is what the function equals, so it's a y value. And that means I can write my ordered pair as 4 comma 7. That's an x and the y value that goes with it. In B, the directions say to find the x value for when g of x equals 16. So remember, if they're asking me for an x value and they tell me what the function equals, that means they're giving me the y value. So I have to set 16 equal to the whole equation so that I can solve that equation for x. So to solve that equation, I keep things organized, and I go ahead and I start by moving the 5, adding 5 to both sides. All right, 16 plus 5 is 21. So 21 equals 3x, and now I have to get x by itself by dividing by 3. When I divide both sides by 3, I get 7 equals x. But now I'm ready to write an ordered pair. I know an x, I know y, so I can write the ordered pair as 7, comma 16. Given the output, I was able to find the input. All right, one more example, and then we'll let you get to practice on your own. Again, I need to find the value of x for which g of x equals negative 8. This negative 8 is a y value, so I need to find the x that goes with it. So when I'm given the y, I take that equal to the equation, 3x minus 5. Now I solve. So I'm going to go ahead and add 5 to start, same steps as last time. And I'm going to get negative 8 plus 5, which is negative 3, equals 3x. Then to get x by itself, I go ahead and divide by 3, which tells me that negative 1 equals x. That allows me to write the ordered pair for this function, knowing that I have an x value of negative 1 that gives me the y value of -8. All right, function notation can be a little bit tricky. So what you need to do is there's a couple problems on the bottom of this notes page. That's your practice. This video is going to end. I want you to try the practice, and if you need help, check out the practice video that's going to be posted on Canvas.